Hello guys, welcome to another video of DevOps. In this video, we are going to compare different infrastructure as code tools. We'll have multiple tools available in market. We'll compare each of them and we'll see which tool you should use and what is the tool is best for your infrastructure as a code design and deployment. Okay, so let's begin the video. We'll be comparing Terraform, CloudFormation, Pulumi, Azure Bicep, and ARM templates. So these are most of the common tools being used, and even in them Terraform, ARM, Azure Bicep, and CloudFormation is the most common. Let's begin the video. Before starting it, let me start by just giving the brief introduction about infrastructure as code, that is also called IAC. Okay, so this is just the coding of your infra and keeping that in your version control so that whenever you need it, whenever you need to create the same set of infra, you just deploy and use the IAC tool deployment command to just create the infra whenever you want. Okay, you can basically code your infra and keep that in your repository. Okay, what are the benefits? This is consistent automation and scalability. You can achieve automation. You can create CI/CD pipelines using your code, infra code, and repository, and you can deploy that to achieve the consistency. You can create multiple set of environments or consistent environments using the CI/CD pipelines, and you can even easily scale the environment as well. If you need to scale your code or scale your infra, you can just change the minor parameter inside your repository or inside your code, and you can scale that as well. Why compare these tools? Because nowadays increasing popularity of IAC, many DevOps engineer and most of the engineers or most of the organizations nowadays are using IAC tools to compete in DevOps. That's why this is important, like which tool we should be using for which environment or which cloud. Okay, importance of choosing the right tool based on use case and platform. These are some of the IAC tools. The first one is Terraform. This is open source multi-cloud support. You can create multiple or you can use Terraform in multiple cloud like Azure, AWS, GCP, Oracle, or any other cloud as well. Second one is CloudFormation. This is specific to AWS. You can also say this is AWS native. You can only create resources with CloudFormation in AWS only. You cannot do that in Azure or GCP. Okay, so CloudFormation is AWS only. Pulumi, this supports multiple languages and cloud providers, but there is a minor difference between Terraform and Pulumi. Yeah, there is a lot of differences in syntax and coding, but at high level, there is a minor difference. Okay, I will explain that later. Azure Bicep, this is domain specific language for Azure, you can say, and you can say the more readable and advanced version of ARM templates, you can say. ARM templates and Azure Bicep, these are both for Azure native, you can say, and this can only be used in Azure. You cannot create infra resources using Azure Bicep and ARM templates in AWS, GCP, or any other cloud because they are developed by Microsoft and specific to Azure. Okay, if you know Terraform or any other cloud language like Terraform or CloudFormation, you will be able to understand ARM templates and Azure Bicep. Okay, they are quite similar. Azure Bicep and Terraform are quite similar. Okay, similarities across tools. What are the similarities? Declarative syntax. All the tools use declarative syntax. Focus on automation and infrastructure management. So all the tools are basically focused on automation. You can achieve automation. You can create CI/CD pipelines using all the tools. Okay, Terraform, Azure Bicep, that can be your CloudFormation or any other tool. Now let's start understanding the Terraform. We'll be discussing Terraform overview and use cases. Okay, this is supported across the platform. You can say cross-platform support. You can use this for you can say like AWS or Azure, and you can even use Terraform from Windows or Linux machines. You can install Terraform inside your Linux agents as well if you want to deploy it from pipelines, and you can install this inside Windows agents as well, even in Mac. So this supports multiple platforms. Okay, we use HCL HashiCorp configuration language syntax to develop in Terraform. This is readable and very easy to understand. If you can a new developer is there, they can go and understand Terraform easily. Use cases: multi-cloud infrastructure deployment. You can deploy, like I have already discussed in my Terraform videos. You can deploy or you can use Terraform to create resources in multiple clouds like AWS, Azure. So if you have requirement, or if your organization is using multiple clouds, you can always go for Terraform and select it. This is commonly used for large scale complex infrastructure. So if you have complex infra or large scale infra, you can use the Terraform. This is the simple example, simple Terraform code snippet to create an EC2 instance in AWS. Like this, you can create multiple resources in either in AWS, in Azure as well. Okay. Second one is AWS CloudFormation. This is AWS native ISE tool. You can create resources in AWS using the CloudFormation. So of course, this is suitable to AWS if you are AWS oriented organization, or your organization is using only AWS. You can always go for CloudFormation. Okay. This is YAML and JSON-based syntax. You can write CloudFormation code inside using YAML or JSON, whatever you might be comfortable with. Use cases best suited for AWS environments. AWS only environments, like I already said, if your requirement is to use only AWS cloud, you can always go for CloudFormation. Automated rollback and stake management in AWS. CloudFormation supports automated rollback and stake management in AWS. So these two the advantages we get when using the CloudFormation. But just remember, this is just for the AWS cloud only. You cannot make any changes or cannot do any coding if you have something to do in Azure or GCP. Okay, this is the example YAML snippet for an S3 bucket creation. The next tool is Pulumi. This is multi-cloud ISE tool with support for TypeScript, Python, Go, and more. So here in Terraform, you can create or you can code your in ISE resources in HCL HashiCorp language. But in case of Pulumi, you get an option to code your ISE resources in Python, Go, and other languages as well. Okay, so if you are a developer and you don't know Terraform language or that SCA language developed by HashiCorp, okay, you can always go for this Pulumi. Allows for a familiar coding experience within ISE because this is developer friendly. If they knows Python, Go, or any other language like Java as well, they can uh, code infra easily. Use cases: hybrid cloud environments. If you have hybrid cloud, like if you are using on premises as well along with your cloud, you can go for this ISE tool. Preferred by developers looking to use traditional programming languages. Okay, this is the example TypeScript code to create an Azure virtual network. You can create type code in the TypeScript, Python, Go, or any other language to create resources in Azure or AWS or GCP. The next one is Azure Bicep. I have already made some of the videos about Azure Bicep as well and Terraform. You can go and watch them. This is domain specific language for Azure, alternative to ARM templates. You can see the latest of ARM templates, like you can say the advanced version of ARM templates, because ARM templates is just simply JSON structure. So for developers, it was very difficult to understand ARM templates now. So that's why they have now converted ARM templates to the Azure Bicep. Azure Bicep is quite similar, and this is declarative, or this is simplified syntax, you can say, in the second line. simplified syntax, modularity, and better readability. You can create modules in Azure Bicep and you can call those modules from your main Bicep template so that you can achieve this modularity and as well, and your templates will be reusable. Okay, the use cases, this is exclusively for Azure resources. You cannot use Azure Bicep in any other cloud, like the name suggests as well. This Azure Bicep contains Azure. This is best for users already familiar within Azure. If you are familiar with Azure or your cloud is Azure, you can always go for Azure Bicep. Okay, this is the example Bicep code snippet to deploy a storage account in Azure. Next one is ARM templates. This is native Azure ISC with JSON-based template. The things which you can do using Azure Bicep, you can also do with ARM templates as well, but the syntax is different. You generally get JSON-based templates with a .json extension in ARM templates. So this is quite difficult to understand if you compare this with Azure Bicep. Strong integration with Azure Resource Management feature. You get all the features of Azure Resource Management to create all the Azure resources easily and as soon as they are available. These are some of the use cases. Azure only environments with a need for high control, well suited for complex Azure configurations. Since this is in JSON, you can create complex Azure infrastructure as well using the ARM templates. Even now, Azure Bicep is supporting all things, but ARM templates are old and they support more. But now Microsoft is providing support for Azure Bicep as well. They are, you can say, they are supporting all the features in Azure. This is some of the example JSON template for a virtual machine deployment in Azure. You can create the template using the ARM templates and Azure Bicep to create the resources in Microsoft Azure. This is the comparison. You can compare all the tools based on some of the features. This is the feature and these are some of the tools. You can just read this table. The first one is cloud compatibility. Terraform is multi-cloud. CloudFormation is used for AWS only. Pulumi is also multi-cloud. Azure Bicep is Azure only. ARM templates is Azure only, like we already discussed. Syntax, we use HCL for Terraform. We use YAML JSON for CloudFormation. TypeScript, Python, Go is for Pulumi. Azure Bicep, the syntax for Bicep is Bicep, and for ARM templates, this is JSON. Modularity, high in Terraform because you can create modules and refer those modules inside your main template in Terraform. CloudFormation is quite low, and in Pulumi it is also high because you can always create the modules in traditional coding languages. In Azure Bicep as well, this is very high because you can create the modules and you can refer that modules inside your code so that you will be able to reuse the templates which you might have created for Azure Bicep and all the resources in Azure. In case of ARM templates, this is medium because generally we don't get a direct feature to create the modules and refer them or call the modules inside your main template. You just get some features like link template, you can say, in ARM templates to call different files. Okay, so you cannot directly call the modules in ARM templates and CloudFormation. The error handling, in case of Terraform, you get plan and apply so that you can first check what are the resources will be created, what are the resources will be destroyed and other things, and finally you can apply it. In case of CloudFormation, you get stack rollback feature. You can roll back the deployment if you want. In case of Pulumi, you get the standard code. Azure Bicep, this is built in, and ARM templates. Everything you will have to do the manual things. So these are some of the key differences between each of the IAC tools. You can refer it. Okay, the important are the first, second, and third one. You can see the cloud compatibility, syntax, and modularity. Now let's discuss the use cases of each tool. First one is ARM templates. This you can use for automation of Azure resource provisioning with native support for Azure. Okay, this natively supports the Azure because this is developed by Microsoft Azure. Ensuring compliance with organizational standard by setting explicit configuration. Azure services integration such as policy and role-based access control for resource governance. Generally, the third point you are seeing here, these are not supported by each tools. Like if you are doing it Terraform, Terraform generally doesn't support all the services in Azure. So that's where ARM templates are good. You can use ARM templates to create each and every resource, each and every property in Azure. Okay, ideal for teams deeply embedded in the Azure ecosystem. So if you are totally in Azure, you are not using any other cloud, you can always go for ARM templates. Okay, now you can even use Azure Bicep as well because Azure Bicep is also good in case of Azure. We'll be discussing in the next slide. Now let's see about Azure Bicep, simplifying ARM templates for Azure focused deployment with improved syntax. So this is just the simplifying ARM templates because everything what ARM templates can do, Azure Bicep can also do. Okay, so you can always select Azure Bicep over ARM templates. Rapidly iterating and testing Azure infrastructure due to quicker template updates. So you can, if you even if you are updating your templates, module templates, you can always go it and test it whenever you want. Suitable for projects requiring strong support for Azure DevOps and Microsoft tooling. So if you are totally involved in Azure, if you are using Azure DevOps for your CI/CD pipelines and other Microsoft tools, you can always go for Azure Bicep and ARM templates. For organizations, transitioning from ARM templates to a simpler native ISE solution. So right now, if you are using ARM templates and you are looking for some of the simple syntax or native ISE solution to Azure, you can select the Azure Bicep. Even migration from ARM templates and Azure Bicep is very easy. You get some of the Bicep CLI commands to compile and decompile your Bicep and ARM template. You can convert your ARM templates directly to Azure Bicep by just running one simple command, and even you can do the opposite as well. Okay, so this is very easy to migrate even ARM template to Azure Bicep. Let's now discuss the use cases for Pulumi. This is multi-cloud deployments requiring a single ISC solution like AWS, Azure, GCP, etc. So if you are deploying multi-cloud environments, you can use this. Okay, for developers who prefer using standard programming languages like Python, TypeScript, etc. to create the resources in multiple clouds. Okay, so this is for developers. If you are using DevOps engineer, I will suggest you to go for Terraform because Terraform is good. I mean, better than Pulumi if you compare it. Okay, but if you are a developer and don't know much about Terraform, you can go for this Pulumi. Third one is applications where infrastructure code needs to be part of the CI/CD pipeline. If you have your application and your infra as well, and they are all part of CI/CD pipeline, you can also select this Pulumi. Teams that need flexibility to create complex resource configuration across platforms. Okay, in this case as well, you can select this language. Pulumi is not that common if you compare this with Terraform, Azure Bicep, and other ISE tools. Okay, now let's see the summary here of each tool. If you compare all the tools with different specs, you can see the differences here. In case of cloud coverage, Terraform Pulumi is multi-cloud. CloudFormation, Bicep, ARM, these are for specific clouds. You can say CloudFormation is for AWS, Bicep, ARM is for Azure. Terraform and Pulumi, these two are for multi-cloud. Okay, syntax complexity. ARM is very high because generally you get the JSON structure. CloudFormation is medium because this is you can say like YAML and JSON. Bicep, Pulumi, Terraform, these are lower because they are simple and easy to understand. State management required for Terraform. For Pulumi, this is not required. Okay, sorry, required for Terraform Pulumi, not required for CloudFormation, ARM templates, and Bicep. All the states are managed by cloud provider directly in the cloud. But in case of Terraform and Pulumi, you will have to manage the state. You will have to store your state file in the remote, and based on that state file, your infra will be created or destroyed. Maturity: Terraform, CloudFormation, ARM, these are mature. Pulumi, Bicep, these are still growing because Microsoft is still developing the Bicep, and still they are working to improve it. Now let's see. This slide will help you to choose the right tool based on your requirement. So if your requirement is to use or to consider cloud platform requirements like Azure, AWS, GCP, or multiple cloud, you can you can just decide what are your requirement. If you want to use the tool for multiple clouds, you can select your tool based on that. Evaluate team's familiarity with programming language like JSON, YAML for templates. You can consider this as well. If your team knows JSON or YAML to create the templates, consider organizational requirements for resource state management. You'll have to consider like you'll be able to manage the state or not. Align with CI/CD policy, information, and scalability needs in your environment. So you will have to consider all these points before selecting the right tool for your environment or for. Okay, so if your requirement is to use or to create the ISC resources in multi-cloud or multiple clouds, you can go for Terraform. But in case of Terraform, you will have to manage the state file, and you will have to store the state file inside your remote or whenever you want, or that can be in your local as well. Okay, and if you want like Pulumi is not that common. If you want, or if you want to use native you can say like development languages like Python, Go, or any other language, you can go for Pulumi. In case of this as well, this is multi-cloud. You can use this to create resources in multiple clouds. So in case of that, you can go for Pulumi. Okay, you can select Azure Bicep if your cloud, or if your requirement to use only Azure cloud, and even ARM templates as well if your requirement is to only Azure cloud. If you have to choose between Azure Bicep and ARM templates, I will suggest you to go for Azure Bicep because this is the latest tool developed by Microsoft, and this is very easier to understand and read and develop as well if you compare with ARM templates. Okay, for cloud formation, this is AWS only. If your cloud is only AWS and you know YAML and JSON, you can go for cloud formation. Okay, this is also, if you know and understand YAML and JSON, this is very easy to understand as well. But if you need multi cloud environments, if you need to create resources in multi cloud or even for one cloud, you can always go for Terraform and Pulumi. But if you have to choose between these two, I will suggest you to go with Terraform because this provides many more features if you compare this with other languages. Okay, that's it from this video. We have discussed everything about all these tools. We discussed the use cases, differences, and many more things as well. Okay, that's it from this video. If you liked it, please like and subscribe my channel. If you have any feedback or suggestion, please let me know in the comments. Thanks for watching.